Thank you everyone for joining us in the session today. My name is Rahul Sareen and I lead the Global Practice for Sustainability in AWS Professional Services. And I have with me two amazing people, Julia Resch, who is the Sustainable Buildings Program Manager at Amazon, and Rob Johnson, who is the VP of Sustainability and Transport at Seattle Kraken. In today's session, we will talk about how AWS customers across industries and public sector engage with AWS to build solutions for their sustainability goals. We will then have Julia, who will share about sustainability at Amazon and the amazing work her team is doing around sustainable building management and the climate pledge. I will then dive deeper on the sustainable building platform that we built on AWS for Julia and her team. We will then have Rob Johnson, who will share about Climate Pledge Arena and some of the sustainability initiatives they are driving at the Arena. We will look at Arena's carbon footprint platform and some of the design decisions that we made. Finally, we will discuss how customers can take inspiration from the two customer stories that we will share today and start their sustainability journey on AWS. It's important to note that sustainability touches everyone, and multiple sectors of society have expressed interest in sustainability and using it as a measure to determine what companies they will invest in, they will work with and buy from. Sustainability plays an important role in valuations, investment decisions, and customer satisfaction. Governments are responding to climate crisis and enacting ambitious policies to reduce emissions. It requires businesses to report sustainability on their sustainability. Governments are responding to the climate crisis and enacting ambitious policies to reduce emissions. It requires businesses to report on sustainability and to decarbonize economies. For example, the European Green Deal will set the EU on the path to be climate neutral by 2050, and the proposed climate reporting rules in the US and UK would create mandatory corporate sustainability reporting. We will hear more about the climate pledge from Julia later on in the presentation. But the climate pledge announcement in late 2019 that Amazon co-founded, it caught attention of many of our AWS customers across multiple industries and the public sector who themselves have adopted sustainability goals as part of their plans. However, sustainability leaders face many business and technical challenges ahead of them to achieve sustainability transformation in real context. For example, they either have limited staff or limited budget, so they have to prioritize projects of high impact while also ensuring minimal operational impact to their business. Or if you see from the technical perspective, they face challenges such as they have legacy systems, or the infrastructure is not able to scale enough, or the data is in different formats and difficult to use. So these are various challenges that all the sustainability leaders we have come across face. And to achieve sustainability transformation, organizations need to move away from manually inputting data into spreadsheets towards a much more seamless data flow that provides automated, accurate, real-time data and ultimately turn those data-driven insights into actions. Customers across industries and public sector engage with AWS, leveraging the depth and breadth of our entire platform to accelerate each stage of their sustainability journey. And an area where we see a lot of focus is on sustainable building or designing, managing facilities. One of the priority areas where we see the ability to measure, monitor, and manage is in sustainable building management. One hotspot that is common across industries is buildings that generate nearly 40% of annual global CO2 emissions. We will talk about two such customer use cases today where we will hear from Julia and Rob about their sustainability transformation journeys they are driving within their organizations, their focus on sustainable facilities, and how they leverage AWS platform to achieve those goals. With this, I would like to invite Julia to share more about sustainability at Amazon.
Thank you, Rahul, for that introduction. Really excited to be here today and really happy that you are here, all of you, with us today. My name is Julia Raish. I'm the global lead for sustainable buildings in Amazon's worldwide sustainability organization. I work closely with all of Amazon's businesses, including AWS, across all of our global regions to drive sustainability solutions in our global real estate platform. Wanted to just start with a moment to tell you about the Climate Pledge, since all of Amazon's work and sustainability in the built environment is rooted in the Climate Pledge. The Climate Pledge is a commitment for Amazon and any signatory, which I'll talk about in a moment, to be zero carbon in all of our global operations by 2040. This is a very large commitment because this is 10 years ahead of the Paris Agreement. And I'll pause for a moment in case you're not familiar with the Paris Agreement. The Paris Agreement is noted as the global treaty that commits various nations and governments and private companies to reduce emissions to address the most pressing and urgent issues of the climate crisis. And Amazon co-founded the Climate Pledge in September 2019 with Global Optimism. And through that commitment, both organizations decided that everybody who signs up for the Climate Pledge would reach those same global treaties, but 10 years early, which is a huge, ambitious goal. If you think about it, if you have any goal in your business for sustainability, imagine accelerating that goal by an entire decade. And as I mentioned, we just passed the 2-year mark of this commitment. And to date, more than 200 companies have signed on to the pledge to join us. And these are called Climate Pledge signatories. And this is a really exciting achievement to have such a large global collective movement. So in case you don't know, the Climate Pledge was co-founded between these two organizations, Amazon and Global Optimism. And Global Optimism is led by Cristina Figueres, and she's an internationally recognized leader on climate action, and she is known as the architect of that Paris Agreement. And we have a shared understanding between Amazon and Global Optimism and all of the signatories that we have a unique opportunity today as a collective group of companies to face climate change head on and build a better future right now, starting today. So I wanted to just make it really clear that the Climate Pledge is not Amazon's alone, and it's not Global Optimism alone. It's a commitment to address climate change and work towards this lower carbon economy that we hope to unfold with many others, including yourselves here today. Because we believe that working with others is the best way to go further and faster against our goals. And to date, over 200 businesses have made the commitment and joined the Climate Pledge, which is a really exciting achievement because this represents over 25 different industry sectors, from agriculture and energy to real estate and textiles. And if these companies all reach their goals, this would help us address 5% of all global greenhouse gas emissions, which would be a major accomplishment towards our broader global climate goals. This group of companies also represents those companies that want to run the furthest and the fastest to address the climate crisis and drive real business change. So a little bit about what is the Climate Pledge and what does it mean to be a signatory and commit to the Climate Pledge goals? Well, it's actually fairly simple. The Climate Pledge has 3 principal areas of action. The first is regular reporting. So we want to measure and report greenhouse gas emissions. The second is to engage in carbon elimination. So this is where we're engaging in decarbonization activities in line with the Paris Agreement through real business change. So working very hard to reduce carbon across all of the major carbon streams, whether that's transportation and buildings and products and packages. And then the third step is to engage in credible carbon offsets. So for any carbon emissions we cannot reduce through real business change, we will neutralize those remaining emissions with additional beneficial nature-based offsets. And through this commitment, we're also working to develop investable pathways to speed up carbon reductions and the resilience of societies at the same time. So along with the commitment to the Climate Pledge, Amazon also maintains other company-wide goals in support of this endeavor. So along with the commitment to be net zero carbon as a company in our global operations by 2040, we are also on a path to power our operations with 100% renewable energy by 2025. We have made significant investments in electrified transportation infrastructure, and we also have a commitment called Shipment Zero, which will mean that 50% of all customer shipments will be net zero carbon by 2030. And we have set up 2 large investment funds to support the advancement of decarbonization technologies and services. And this helps us look around corners and see where, as an industry, not just ourselves, maybe we're getting stuck. Maybe there's some blockers out there to engage in that real decarbonization. And so we want to figure out how we can invest in that step change reduction. So what to focus on today is really around the energy and decarbonization throughout all of Amazon's operations, and how the Climate Pledge commitment and goals and the other company-wide goals I just mentioned apply to our built environment. So the work that I'm really focused on in the Worldwide Sustainability Organization is through understanding how can we measure and disclose our emissions, engage in that real decarbonization, focused on energy, sustainable buildings platforms, and using data in conjunction with AWS to really engage this global infrastructure network that we have today at Amazon. So the team I'm on, we set a lot of vision and goals and strategy and roadmaps, but I want to acknowledge the hundreds of people here today, both at AWS and the rest of Amazon, that are doing a lot of the hard implementation and execution against these ambitious goals. And we're going to talk today a lot about the data architecture and how data really supports us meeting the Climate Pledge commitments in our buildings. But at Amazon, sustainable buildings mean more than just reducing the carbon of this built environment footprint. We also care about other resources such as water and waste, and we want to ensure that our built environment is creating positive outcomes for the people who occupy these buildings, be it vendors, visitors, customers, as well as the communities where we build. So wanted to just pause for a moment and note that while the program has a very holistic focus, today we'll be really deep diving on that first focus area, which is zero carbon. But luckily for you all, later today in the presentation, Rob will share how the Climate Pledge arena is really driving that holistic program that we're striving for across our network. So you're probably all wondering, well, how are we getting this done? We don't have everything solved today, to be honest. We have a very complex network of global buildings. We have thousands of buildings across the globe in every region. We work across 4 major market verticals: corporate offices, data centers, a really large portfolio of retail, and of course, an even larger portfolio of customer fulfillment building types. And this diverse footprint serves a whole variety of stakeholders and occupants and customers. And so we're trying to right-size how we take this broad goal and this commitment and apply it across this really diverse footprint, which is a pretty difficult but also really exciting task. So we'll talk a little bit about how we've started to do that and share some successes and where we're also learning. So in line with the Climate Pledge, which the first principal action being to measure and report emissions, Amazon does measure and report the carbon footprint associated with our entire company, but also our buildings on an annual basis. And using AWS's data platforms, we're looking to do that with increased cadence and, of course, increased quality over time. And as many of you know, there's 3 principal ways that buildings contribute carbon emissions into the atmosphere. So the first is through on-site combustion of natural gas that might be used for domestic hot water, heating and cooling systems. Most buildings have diesel generators, and also the refrigerants that are used in, particularly in our retail network, for refrigeration systems to keep food cold, and also the refrigerants used in heating and cooling systems. And then the second way that they produce emissions is through all the electricity use, which we track across the entire network, including all of the renewable energy that we purchase to offset that electricity use. And then the third part is what is known as Scope 3, or the embodied carbon. And those are carbon emissions that are released into the atmosphere through the manufacturing of building materials, transporting those materials to the project site and constructing those in the building. So every year we track those, we disclose those, and these are all publicly available on our website should you want to dig in a little further. And so now that we have measured this footprint, we can start to manage it. So now we're engaging in carbon elimination in our built environment. And so as a company, we are headed to a transition to net zero carbon buildings globally. And that's across offices, data centers, the retail footprint, and the customer fulfillment network that I mentioned earlier. So not an easy task. And we have some ways that we've unlocked and decarbonized in parts of our building, but we still have a lot to learn and a lot to scale. But through the data insight and the continued insight with partnering with AWS's data systems, we now understand where we are today and where our opportunities are for improvement over time on our path to change. So the way that Amazon as a company defines a net zero carbon building is one that is designed to be all electric. So it removes all of that on-site combustion that I mentioned before. The second is to use low global warming potential refrigerants or natural refrigerants. So refrigerants, although maybe not the largest part of a building's carbon footprint, are very harmful to the atmosphere. And so we are looking to change out the type of refrigerant that we're using to be less harmful to the atmosphere, or to transition the system more holistically into a completely different design. I'll talk a little bit in the next few slides about how that's been accomplished or maybe difficult to do. The next piece is that we want to make sure our buildings are very energy efficient. So since we have this goal to power our buildings with 100% renewable energy, we also need to drive our energy consumption down. And AWS is quite a leader in this space, and across our portfolio, we've taken a lot of great learnings from AWS's energy efficiency efforts. And then whatever energy we can't reduce through real change, we will power that with 100% renewable energy. And then the last piece is to reduce the embodied carbon of those building materials. So things like, could we get steel and concrete and building insulation that has less carbon emissions to make and deliver to the site than what we might be using today? And so working with our procurement and supply chain partners on that change. And whatever residual emissions remain after taking those steps, we will engage in carbon offsets to offset the rest. So as many of you can imagine, this is not a light switch. This takes a lot of determination and grit and patience. And to be honest, we are still early in our journey, and we have a lot more to do with a lot of these topics above. And in some of the cases, the industry is really ready for us and asking us to engage. They have technology, they have market-ready solutions. And in some of these other decarbonization steps, we're navigating through some blockers of policy and code and technology and education. As an example, making the change in refrigerants, some of the technology is there. But at Amazon scale, there may not be quite enough technicians knowledgeable to help us should we need any kind of maintenance or ongoing maintenance on the facility. So we're hoping that as we learn that we are able to share our efforts with others, not just yourselves here, but to package our learnings more broadly for the industry. So we have a couple wins I wanted to share quickly before I turn it back over to Rahul. So what does some of that list mean in reality? Well, we love the first pours that we've done in our buildings on low carbon concrete. So we've been changing out some of our concrete to have less carbon emissions, and some of our first projects are now starting to pour that concrete, which is really exciting. We're also about to launch a small handful of very low carbon or net zero carbon buildings in the next 6 months, so keep your eye out for more on that. But a lot of the work in the space is about process. It's about process changing and getting our design and construction mechanisms in place to drive that process change. It's not all shiny objects, but we're really excited about what's been developed, including the centralized data systems that have been leveraged in all of our global real estate in partnership with AWS to really help us understand how to track and enhance the building performance over time. So on that note with analytics, the data piece, as I mentioned before, is really critical. And what we've learned is that it's an iterative process. It's never really done. With such a big, diverse portfolio that Amazon has, chasing data is always the reality. We don't have perfect data. We don't understand everything about the nuts and bolts of how all of that global portfolio is performing. So working with AWS's digital platform has been critical to unlock that data, to help us go faster, and to help us go forward with a lot more intelligence that we need. So just a quick note before we dive into this with Rahul, we have deployed this analytics platform across the portfolio in well over 300 buildings so far, and quickly scaling in each of those 4 major portfolios, including both new design standards, so that this is the standard going forward for all of our future buildings, but as well as retrofitting our existing building stock with this analytic platforms, and looking to continue to scale across that portfolio. So I am not the data platform expert. If you want to talk about concrete, reach out to me, but I'm going to turn it over to Rahul, who's going to do a deep dive into the Sustainable Buildings platform that's helping us meet our goals.
Thanks, Julia, for the amazing presentation. Now, Julia presented about the sustainable building and the operations that they are doing in the building management space within Amazon. Let's dive a little bit deeper on the sustainable building platform architecture that we built for her and her team at Amazon. When we started the project with Amazon Buildings team, we found our existing building management systems, they could not provide data in a structure that was easy to analyze. Furthermore, access to data across buildings was difficult, with little standardizations in the data. Finally, as we looked to support Amazon's sustainability goals, we were looking for ways to control the power state of devices through the cloud to achieve real savings. With that said, we started working with our integration partner CBRE to add control logic and libraries to the BMS systems and designed our backend analytics platform accordingly. This platform only ingests data that we really need from the BMS and removing all the rest of the noisy data that we don't need. And we complemented the BMS feed with new sensor and utility data sources. What helped us was that this ultimately delivered a new, streamlined building systems reporting platform that is highly flexible and modular, but it's built on scalable foundations. One area of focus that Julia mentioned in her presentation was around utilizing energy efficiency technologies with Amazon in order to achieve their net zero goal. Our team is building ML-based digital twin to provide optimum condition for running energy-consuming assets such as HVAC systems, lighting systems, electrical systems. Another area that our team is focused on is building forecasting models to accurately predict future energy demand based on historical trends and various environmental factors. And this is one example of the operational energy management leveraging AI/ML, where we are helping reduce cost and energy consumption of the equipments by optimizing equipment efficiency. So we are trying to find the optimum set point or the optimum condition in which to operate an equipment so that it consumes less energy, less water, or less resources, and then doing simulation to match it with the real-time data and predict what should be the actual optima or the likely optima of operating. And our initial results have gotten good traction where we were able to reduce energy consumption for equipments all the way from 5% to 25% at the first part. Now let's dive a little bit into the backend data architecture that we built. As you can see, we are ingesting data from our edge devices or the BMS systems into AWS through AWS IoT Core. We then have rules set up to route the data based on whether it is a near real-time data or a batch data. Our architecture addresses both the scenarios. For near real-time process, data comes to the AWS Genesis stream which is then accessed by multiple data consumers based on the different needs of business units. Later, we store the data in a time series database that is then used for visualization using different reporting and dashboarding frameworks that Amazon has. And for the batch process, data flows into Kinesis Firehose, which buffers the data and lands it in an S3 raw format. Data is then partitioned, transformed, and stored in a curated bucket for querying. Again, it's used by various businesses within Amazon for various purposes. Next, let's talk about the backend sustainability data lake. The sustainability data lake ingests data from the building management systems for the raw telemetry data. However, to gain insights into building operations and compute the required KPIs, we will also need to ingest data from other enrichment sources. So think about on-prem databases or ERP system, location data, weather and public utility data, or even from our renewable energy fleet. As Julia mentioned about Amazon's investment in the renewable energy, we are also getting data from all the renewable energy projects that are running for Amazon into the same sustainability data lake. And using the different compute mechanisms we spoke about in the last slide, the curated data can be made available in various purpose-built storage systems. So we use S3 for raw formatting, we use Amazon TimeStream for the time series data, and Amazon DynamoDB for some metadata information that we need to store. And finally, the curated data is then passed to SageMaker for building ML models. Some of them I described earlier for energy management and optimization. Finally, all the infrastructure components and the code is deployed using a DevOps pipeline. All the infrastructure is defined as code with the Amazon Cloud Development Kit. We use the AWS code tools to deploy this into respective accounts. And what we have implemented is the best practice designed for security, such as using multi-account strategy to limit blast radius. So as you see here, we deploy it in the production account, and we also have a mechanism to deploy it into dev and test account for various purposes. Now, this is a sample dashboard that shows various views that we have built for different user personas within Amazon. We have a map level view that shows all the buildings with some high level attributes displayed on the map. Then we have an operational dashboard on the left that shows different values such as energy consumption, even broken down by equipment and by sources. And that's basically very useful for the operation people to know what the carbon and the energy hotspots are so that they can take some decisions to reduce it further. And finally, we have a broken down chart by different scope categories across the building in the third graph that you can see where we define it as to what's your scope 1, scope 2, and scope 3 carbon footprinting. And then we have recommendations for operational efficiencies by providing both ML-based and manual recommendations. With this, I would like to invite Rob Johnson, who will share his journey for Climate Pledge Arena and the partnership with the Arena with Amazon and AWS.
Thanks, Rahul. Nice to be with you all today. Again, my name is Rob Johnson. I'm the VP of Sustainability and Transportation for the Climate Pledge Arena and its chief tenant, the Seattle Kraken. I'm here today to talk to you a little bit about our work to be the world's first net zero carbon certified arena and live entertainment venue on the planet. To meet that net zero carbon certification through the International Living Futures Institute, a building like ours has to do 4 major things. The first thing that you have to do is totally eliminate your fossil fuels from the building. We were under construction when we made this decision, and we had several places where we thought we might have some natural gas in the building to power the energies, the arena's energy use, the boilers that we need to heat the building, et cetera. We eliminated all those fossil fuel-based components and replace them all with electric components. The second thing that you need to do is you need to have some visible components of on-site solar panels. So we're doing that in a couple of places. You'll see some good visuals later about where we've installed solar panels to help generate, I think, about 3 to 5% of the total energy used by the building through on-site renewables. The third thing that you need to do is you need to go out and procure the remainder of your energy from new renewable sources. We partnered with our partners at Amazon as well as Seattle City Light to go out and procure that new renewable energy from a couple of different wind and solar farms here in Washington State. And then the final thing that you have to do is you have to account for 100% of everything going on inside the building. The carbon footprint of the hammers that we need to buy, the carbon footprint of the food and beverages that's coming to and from the building, the carbon footprint of the merchandise that we sell, all of that needs to be accounted for and offset at the end of a calendar year. In addition to that certification program through the International Living Futures Institute, we've also set off to do some other really cool things. Inspired by our architect who really designed the roof in 1962 as an homage to a traditional Native American Coast Salish rain hat, this brand new building held up that 1962 historic landmark roof, dug a $1 billion building underneath it, and reconnected it back up to that roof. And in doing so, we also connected it to a brand new 15,000 gallon cistern. So we're capturing rainwater off 1/4 of that roof, holding it in this underground cistern, and using that rainwater to resurface the ice for all of our home hockey games and practices. So saving us probably 50 or 60,000 gallons of water annually, which is a relatively small amount, but significant when you think about the total drought and water supply shortages that we've seen throughout the West in the last several summers. In addition to our Rain to Rink solution, we're going to be banning single-use plastics. We've set out to eliminate as many single-use plastics in the building as we can. You won't see any plastic straws. You'll see very little plastic packaging. You won't see any plastic utensils. And we're set to phase out all plastics inside the building by 2024. That's when our partners at Pepsi will have been able to eliminate 100% of the plastic bottles that you'll see inside the building. It's really important to us because you can see the Puget Sound from our front door. And as our region's largest estuary, it's demonstrable the scientific impact that microplastics are having on the health of our native salmon and orca populations. So the more we can eliminate those single-use plastics from our building, the better our Puget Sound is going to be, and the healthier returns of our salmon and orca populations will be. In addition to that, we're doing some really great stuff in sustainable and healthy food. 75% of our food is going to be sourced from within a 300-mile radius. House wines and beer coming from Oregon and Washington. We've gotten a bunch of really great certification programs. We're going to be serving a lot of vegan and vegetarian options, which not only is great for the planet, but also pretty on brand for the city of Seattle. And we're going to be aiming to be functionally a zero waste facility. With our partners at Waste Management, we're going to endeavor to make sure almost everything in the building goes into a composting or recycling bin. Hugely important for us, again, as we try to create a closed loop system that ensures we're delivering less and less into our landfills and more back into things that can be recycled or composted. When you think about the big challenge that I mentioned earlier of Scope 3 emissions, transportation looks like it's going to be the biggest component. Somewhere between an estimated 50 and 60% of the emissions associated with our building are going to come from people and stuff coming back and forth from that building. So we're trying to tackle that in innovative ways. We're implementing an artist-led carbon offset to cover the emissions from artists who are coming to and from the building. You've got somebody like Coldplay who came recently. They're coming up with 19 semi-trucks from LA. They might be taking a private plane. All of those emissions need to be offset. In addition, any fan who's buying that t-shirt that night needs to be offset. So we're making sure that we're offsetting all those emissions. And from a transportation perspective for fans coming to our home hockey games or home Storm games, they're going to get a free public transit ride along with their ticket. All of this is wrapped up in a $7 million investment that we've made in the monorail, which is also built in 1962 for the World's Fair. It's a 90-second ride from downtown, and it's inexpensive parking and great public transit options to our front door. We're really excited about the work that we've done to date, but we know we've got a lot more to do. We've got to collect a lot of that Scope 3 emissions data coming from a diverse set of business lines, which are coming in wildly different forms. I've got some vendors who are very sophisticated and are doing instantaneous API calls with AWS for us to be able to ingest that data in a data lake. I've got other folks who are really just trying to get me gross numbers of retail sales so that we can use that to extrapolate the total emissions factors as part of the GHG protocol. We're developing a new set of systems here, which requires us to develop a business as usual test case, as opposed to what you might be able to do with a more traditional building, setting standards based off of their existing operating characteristics. That's not possible here. The building's only been open for a couple of weeks, so we're building this plan as we're flying it, as they say. And all of this leads to what I think is probably the most important point that I want to make today, which is that we're intending to do something that we think no sports team has ever done before, which is really to have a detailed carbon accounting associated with 100% of our building's operations. That wouldn't have been possible without the partnership at AWS. And to do that carbon accounting also means you've got to have really, really great stories to tell. These two things together, the carbon accounting piece and the storytelling piece, we hope are going to inspire our fans to continue to take this journey with us, to know that we're going to be better on day 366 than we were on day 1. And we hope it's going to lead folks like you to really think about how you can work hard to develop your own carbon accounting system and really be able to tell your own stories to your compatriots and your competitors, and make sure that we're all taking critical steps in this next decade to really reduce our own environmental impact. So with that, I'll turn it back over to Rahul to talk to you a little bit more about our carbon footprinting and its platform with AWS.
Thanks, Rob. Exciting to hear all the innovation going on in the arena. Let's take a look at the carbon footprint platform that we developed for the Climate Pledge Arena. Before I dive into the architecture, let me define some key terms that we will use when discussing greenhouse gas emissions. So greenhouse gas or GHG emissions, as we say, are produced by a company's supply chain and have both direct and indirect causes. To better distinguish between these direct and indirect emissions, GHG protocol divides them into 3 categories: Scope 1, Scope 2, and Scope 3. Scope 1 emissions come directly from a company's activities related to delivering the product or service, including operations. And Scope 2 and Scope 3 cover the indirect emissions upstream and downstream from the process in question. And when discussing the reporting of greenhouse gas emissions, a common term used is carbon footprint. A carbon footprint is the total greenhouse gas emissions caused by an individual, event, organization, service, place, or product across all the 3 scopes I mentioned earlier. And rather than expressing the amount of each different greenhouse gases separately, so if you see in the slide, there are 7 or 8 different greenhouse gases that encapsulates the GHG emissions, like carbon dioxide, methane. What we do is, rather than expressing the amount of each different greenhouse gas separately, all the greenhouse gases are expressed as the carbon dioxide equivalent, or what we call it as CO2e. When we started building the carbon accounting platform for Climate Pledge Arena, we quickly found that it was largely a data problem, with data availability being the largest challenge. But even if you get the data, it's in different format types. So for example, some data came in PDF document formats, while others had APIs built in, and it was very difficult to get all of that in a same format with the same schema, with the same units. For example, we got data in XML, some had different layout from the utility bills. Also, the data volume that we are talking about can be huge. So we needed a scalable storage solution to store all the raw and processed data for further analysis. And then finally, we needed to provide all the data in a seamless manner to different stakeholders through either a web portal or APIs. As I explained earlier, the biggest challenge working with data was around data acquisition and ingestion. In order to accurately calculate the Arena's footprint, we needed to work closely with Arena's business partners to ensure that they report all the needed data. These are examples of some of the Arena's business partners who we started engaging for data acquisition and also the frequency or the type of data collection. And as you see, right, one of the patterns of data ingestion from vendors was that they provided either a file-based data or either in CSV or PDF formats. We also worked with some vendors and they were more mature in their IT, and we worked with them to acquire the data in the form of an API response. So we just plugged into their API and directly pulled the data from there. Now, I'll quickly talk about a very simple calculation of how we do Scope 2 emissions. Just for your information, this is a very simple representation of the calculation methodology. There is a lot more complexity that happens in the back end, and it's not even a comprehensive formula, but this is just to give a perspective of how we come up with the CO2 emissions. So as shown on the slide, this is the formula prescribed by the GHG protocol, where we multiply the activity and the emission factor to come up with the CO2 equivalent. So the kilowatt hour of electricity from the utility bills is then multiplied by a region-specific grid average factor published by government agencies such as US EPA. Then we multiply and get the final output for the CO2 equivalent. We do this for all the activities and then aggregate to come up with a final CO2e number. And most companies, so carbon accounting is not new, right? Most companies measure carbon footprint, but they use Excel files, and it's a highly manual, error-prone, and painful process. And that's where, when we started working with Climate Pledge Arena, we decided that we will take a technology-first approach and we will build a technology platform that can help companies monitor, report, and reduce their carbon emissions seamlessly. So let's review the backend architecture that we built for calculating the carbon footprint of the Arena. As you see, we have data which is coming from different sources, different formats. So we have files, we have data coming through APIs, we are also pulling data from some databases, and we also have a web portal where the admins from the Climate Pledge Arena team are actually going and manually entering the data. On the top left with the gray box, we have an automated data pipeline that is processed once a day. For this data ingest strategy, we work with partners that I mentioned earlier, and they directly upload the files to S3. And after we validate the data, it is then finally enriched with carbon values using the emissions calculator microservice that I will talk later down the presentation. And we understand that not all data will be available in an automated fashion, and some of the challenges I explained earlier. So what we did was we built a web app, as you can see from the bottom right box. So the Climate Pledge Arena employees can log into the portal and provide activity data by submitting info into the forms on the portal. We are also planning to basically extend it so that when Arena starts providing these surveys, then we'll have all the survey results automatically coming in and then ingested into the backend database. But that's the later phase. But for now, the activity data that's entered manually is validated and enriched using the same techniques as I described in the previous slide. Then we store the curated data in different places based on various use cases. And finally, all the activity data that comes to the database, we send it to the emissions calculator microservice that outputs the response with the CO2 equivalent from that activity. Now let's double click on the emissions calculator microservice, which is the main component of this architecture and which is doing all the heavy lifting of coming up with the final carbon number. And this is the architecture for our carbon model microservice. The microservice includes a repository, which is dedicated to the carbon model and is managed by either an environmental or an LC expert. The LC experts builds a carbon model and submits it in the portal, which is then converted into a Python library where all the activity types are mapped to the calculation that is required to determine carbon emissions. Then we have an emissions factor microservice used to store current and historical emission factors. We have a jobs setup that periodically updates the fact store to the most current values from LCA databases or public sources, depending on where exactly the emission factors you are getting from. And then the carbon model microservice uses the latest table model, which is stored in S3, and provides a response with the CO2 equivalent with all the metadata that we save to repeat the calculation if need be. This slide depicts the relevant activities which are contributing to the GHG emissions at Climate Pledge Arena. For the carbon footprint assessment, we considered various inputs such as diesel consumption, grid electricity, purchase, procurement of building materials, transportation of teams to and fro from the arena, attendees, and even waste disposal. If you notice the thickness of the arrows, you can see that scope 3 arrows are the thickest compared to scope 1 and scope 2. And that's not unusual. Typically, scope 3 emission sources contribute to over 50% of an organization's carbon footprint. And companies usually don't have visibility to track these impacts. And that's why working with the vendors become very important here, because for scope 3, you need to make sure that you have a good visibility and good data access across your supply chain. And even for the portal that we built for Climate Pledge Arena and the dashboard, we worked with the arena's vendors to obtain data for all the activities. We will soon have a public-facing dashboard which will be available for everyone to see the carbon footprint that I'm sure Rob would be happy to share with the public on the arena's activities. Now that we have walked you through Amazon and the Climate Pledge Arena use cases, let's take a minute and talk about how you can get started on your sustainability transformation journey. Many AWS customers are coming to us with questions about their sustainability projects, use cases, and best practices to achieve their sustainability goals. They are asking questions such as, how do I identify carbon hotspots? Or how can I collaborate with my vendors across the supply chain to reduce carbon emissions? Others are asking, how can they use emerging technologies to optimize their operations? So there are a lot of questions that customers are asking and AWS to help solve. And while working with these customers across many industry segments and public sectors, what we have observed is that these organizations have many use cases they want to tackle to meet their targets. And what we recommend is start small. Break down these lofty goals into smaller, short-term projects that then act as building blocks to meet the larger goal of sustainability. And AWS offers a list of programs depending on where you are in your sustainability transformation journey. Check out the AWS Sustainability website. It has information about how AWS implements sustainability in our operations. So all the work that we are doing in our data centers to make them more efficient, the renewable energy that we are procuring to run our data centers. Plus, you can also look at various case studies and use cases on how AWS customers are leveraging the platform to build sustainability solutions. Second, you can leverage AWS ProServe or professional services team to utilize our sustainability expertise and offering, run discovery workshops, or enablement of your internal staff. So as I mentioned earlier, I lead the sustainability practice for AWS Professional Services. And what we do is we help our customers accelerate their sustainability transformation journey through data-driven insights. And we are a group of consultants, including former chief sustainability officers and sustainability industry experts, who help AWS customers build long-term sustainability strategies. And then we have a team of sustainability technologists who can architect and develop solutions leveraging emerging technologies and the AWS Cloud Platform. Third, you can build your solutions using 100 plus services that we have on AWS and our partner solutions, which are available at our marketplace. And finally, you can check various tools that we offer, such as Amazon Sustainability Data Initiative or AWS Data Exchange, to find sustainability datasets for research and innovation. And you can check more information about all the stuff that I mentioned earlier on AWS Sustainability website. I would like to thank again each one of you who attended this session. I hope this session was meaningful to you, and I cannot wait to see what innovative solutions you build around sustainability on AWS and help make Earth a better place. Thank you.